Ladies and gentlemen, on behalf of the Student Association of Energy, allow me to welcome you to the 10th lecture of our memorial semester, named after the 150th anniversary of the establishment of the Faculty of Mechanical Engineering. Today's lecture is about the new nuclear energy future. It is a special honor to me to introduce William D. Magwood IV, who is the Director General of the OECD Nuclear Energy Agency, as today's presenter. William D. Magwood will present recent analysis that highlights the role that SMR and Generation 4 reactors can play in addressing the historic challenge of reducing carbon emissions and the major barriers to success. He will also highlight initiatives conducted by the NEA to support its members in addressing the human capacity and scientific infrastructure needs of the future. The lecture will be 60 minutes long, and at the end, we will ensure 15 minutes for your questions. I respectfully ask William D. Magwood to give his lecture. Thank you.
Thank you. Good evening. Good evening. Hello. I know it's late, but wake up. I want to start with a question, and please answer by raising your hand. How many of you believe that climate change is real? Okay, it's pretty close. Keep them up. Keep them up. All right. All right. So, all of you who believe climate change is real, hold your hands up. Keep them up. All right. Those of you who are convinced that we will solve the problem, keep your hand up. The rest of you, put your hands down. Okay, we're down to about a third. Yeah, I think you're actually a lot of optimists here. When I asked that question, because we just had COP26, I know many of you were watching the news about COP26 that was held in Glasgow just a few weeks ago. And if there's one thing I think that came out of COP26 that was really important from my perspective, is that I think that more people realized how difficult this is going to be, how big the challenge is. And what I think people also had to recognize was if we're going to solve the problem, we're going to have to use all the tools in our toolkit to be able to address it. So I'm going to talk a little bit about that today. But first, of course, I'm going to start with a little bit of a commercial, which is to tell you a little bit about the Nuclear Energy Agency. So the NEA has been around for about 63 years. We have 34 member countries, including, of course, Hungary. And the countries in the NEA are countries that have long experience with nuclear technology and science, regulation, and policy. We work with a variety of countries who are not members around the world, such as China and India, but we bring countries together to cooperate to solve problems and to bring experts together to think about how to make nuclear power work better, safer, more effective, more economic, and to deal with issues such as nuclear waste and radiation protection. Increasingly over the last several years, we've spent a lot more time working with universities, NGOs, and industry. The NEA also includes research projects. We have 28 research projects currently underway on a variety of topics. We're also the home for big international initiatives like the Generation 4 International Forum, the Multinational Design Evaluation Program, which brings regulators together to look at state-of-the-art technologies, and the International Framework for Nuclear Energy Cooperation, which brings highly developed countries together with emerging economies to talk about the future of nuclear and to discuss the issues related to nuclear waste, human capacity building, and other issues. One of the things that we've been doing most recently is been getting a lot more involved in human capacity issues. And one of our most important programs is called NEST, the Nuclear Education Skills and Technology Framework. Through NEST, we bring students from universities around the world to work together on a multinational basis to work on real live programs and projects to become trained in a way that you only can get from very large research activities. which unfortunately aren't as common as they were back in the 1950s and 60s. So we try to replicate some of the advanced research activities that people used to see through these multinational initiatives. We have a range of projects. One I'll highlight here is a project that is taking place in cooperation with the Japanese, where students are working on robotic technology that will be used to decommission the Fukushima nuclear power facility. The students will actually go to the Fukushima site and see the robots in operation and work on different technologies. Other students will be going to Siberia to work on the disposal of irradiated graphite. Other students will be going to Italy to work on medical isotopes. Others will go to Switzerland and work at PSI and working on nuclear safety issues. So there's a wide range of technologies where students will be moving around the world. Hungary is not yet a member of NIST, but with your professors here, I'm going to say it's time for Hungary to be in NIST. It's time for you to join the fund. So we'll be talking about that later today, and I want to really encourage that Hungary join this program and become part of this. Another program that we're doing is we started something this year called the Global Forum on Nuclear Education. This is one of the more exciting things for me. This is a global framework where university academics from around the world will work together. Believe it or not, nuclear has been around for about 70 years now, but there's never been a standing body that brings universities around the world together to cooperate to solve issues related to nuclear academic issues. Now we have one. The Global Forum right now is focused on 4 major topics, and I'll just sort of talk about those very briefly. And these are the people who are co-chairing these discussions. The 4 topics include, as you can see on this chart, how to achieve gender equity in the nuclear sector. That's an issue that's growing in importance around the world. Looking at the future of nuclear education. In many countries, nuclear departments aren't as academically active as they used to be, not as innovative as they used to be. So we want to talk about that. Rethinking the relationship between nuclear energy and society, obviously very important, especially in countries that want to continue building nuclear facilities. And also identifying ways of revitalizing innovation in the nuclear field. So these are areas that the Global Forum will be working on. There'll be other areas as well. And it's a very exciting opportunity. And we expect to involve not just the professors and the deans and the provosts, but also involve students from time to time as well. So keep your eye on that. Lastly, a very high priority from our leading committee is to do something about gender balance. This is a project that we've been working on for about a year now, and we've already made some pretty good progress. The NEA has launched 2 major surveys. One, we've got responses from 17 countries among our membership about the role of women in nuclear industry, universities, laboratories in those countries, what level they have, what pay they get, what training they receive. So we have a lot of quantitative data from these countries. Probably more important, we did a qualitative study where we asked women from around the world in the nuclear sector to talk about their impressions. We received responses from almost 9,000 women around the world working in the nuclear sector. So we're now in the process of compiling all this information, and our objective is going to be able to suggest solid, tangible, meaningful policy changes that countries around the world can take almost right away to make a change, to make a difference in gender balance. And we expect this to be brought to the OECD Council, which can make it basically a law for OECD members. So that's something we're very excited about, and hopefully within next year we'll be able to get that done. So that's kind of what we're doing at the NEA. Now, most of what we do, of course, is in the science and technology and economics area. And over the last several years, I don't think there's anything that has had a bigger impact on our work at the NEA than this issue, the issue of climate change and the Paris Agreement, which we talked about when I started. And I mentioned that I thought the COP26 highlighted for people around the world that this is a very difficult challenge. But for people inside the energy community, we knew this was hard a long time ago. And I'll point to this chart, and this comes out of an OECD study that was launched a few years ago that highlights that if you were to meet the Paris Agreement requirements for the 1.5 degree scenario, that in OECD countries in Europe, North America, South America, for those countries that have these very large, very extensive electricity infrastructures, they would have to reduce emissions from electricity generation by 85%. So if you know how big and extensive the electricity infrastructure is around these countries, the idea that we're going to reduce emissions by 85%, if nothing else, that should show you how big the challenge is. Well, so it's no surprise that we're not doing very well. Probably the most interesting number that I've seen is when the IPCC, the International Panel on Climate Change, Intergovernmental Panel on Climate Change, noted that while the target had been to reduce CO2 emissions globally based on 2005, the 45%, reduce 45% by 2030. If you look at the current commitments that countries around the world have made, and very stringent, very tough commitments in their minds, emissions still rise 13 to 16%. So we're not going the right way. And so that's something that has been very sobering. And I think in COP26, people were really, I think, frustrated that we weren't able to do better than this. So there's going to be an effort to try to push countries to cut even more. But there's a limit to how much countries can do when they tie their hands behind their backs. And I think a lot of countries have done that by taking nuclear out of the equation. So a few observations. In addition to the challenge of climate change, electricity use is going to skyrocket in the coming years. Across all sectors, we see in the industrial sector, and particularly in transportation, a move away from the direct use of fossil fuels, away from oil, away from coal, away from gas, towards use of electricity. As I said, transportation, this is going to be one of the biggest. So electric vehicles seem to be on the verge of taking over the market. Manufacturers around the world are de-investing in engine technology and moving all their investment into electric vehicles. So electric vehicles are coming, and they're going to be coming in a very big way over the next 10 years or so. And the electricity system has to keep up with that. Coal around the world is disappearing. It's really quite remarkable to see how fast countries are beginning to shut down their coal capacity. It's happening, I think, faster than I thought was going to happen. And certainly, I think it's happening faster than many countries are prepared for. So this is a big challenge, but it's a reality. And 2030 has become very important. You know, for many years, we talked about 2050 as a target for reducing CO2 emissions. And countries originally had said they wanted to reduce by 75 or 80% by 2050. And then things started to get more aggressive. Then they said, well, we want to be net zero by 2050. But then someone realized, well, 2050 is such a long way away. You're able to have lots of, magic between now and 2050. We can imagine technologies that will suddenly show up and suddenly make it easier to go to net zero. So let's bring the targets forward and see what happens. So 2030 became a target. And 2030 is 8 years from now. And we're not on target to meet that. But what it's done is crystallized in the minds of a lot of policymakers and analysts around the world that the challenge is right in front of us and we're failing. Before, it was so far away they didn't worry about it. But now I think it's really gotten people worried. So as I said, many countries have come back to nuclear. Nuclear had been a very popular part of the conversation, say, 15 years ago, before the Fukushima Daiichi accident. We are back to that now. We're back to where more and more countries, including countries that would probably surprise you, are talking about nuclear power as part of their future and part of their strategy to reduce CO2 emissions. Our work and all of our reports, you can check our website, you can download what you like. Our work shows that if we're going to be successful in even approaching the reduction that countries are talking about, we are going to have to use every technology. We're going to have to use renewables. We're going to have to use carbon sequestration if that actually works. We're going to have to use fission technology. Everything will have to come into play if we're going to have a chance to make this work. The problem we have today is that the markets don't really support those initiatives. The markets around the world are largely broken, to be honest. They don't work very well. They don't send the price signals the industry would need to make the right investments. And this has proven to be a real impediment to progress. But one of the things that we have done is we have a system of analysis that we call system costs, where we look at the total cost of generating electricity. And I'll give you an example. So it's very common for people to look at, let's say, a wind farm and compare the electricity from the wind farm to the cost of a nuclear power plant. And they'll say, well, the nuclear power plant costs a lot of money, and with the cost of generation and regulation, the wind farm is cheaper than the nuclear plant. You hear this quite often. But if you look at it from a system perspective, when you look at the wind, you have to include some factors that the nuclear plant doesn't really have much to worry about. For example, wind is usually located pretty far from demand centers. So you have to spend a lot of money on transmission to move the power closer to where you're going to use it. There's a cost to that. That often isn't factored in. And also, the wind doesn't blow all the time. You know, when the wind is blowing, it's great. When the wind's not blowing, you have to supplement it with something else. Typically, in most countries, it's supplemented with natural gas systems. But there's a cost to having a gas turbine sitting on standby waiting for the wind to stop blowing. And sometimes it's a substantial cost. So when you add that all up, you find that wind and PV and other renewables are not as cheap as you think they are. And when you really look at it soberly and you look at it seriously, you find that the sweet spot for most countries around the world is probably today, based on the technology that we see coming over the next decade or so, maybe 40 or 50% variable renewable energy. That's probably the most you're going to see in most countries that will be anywhere close to being economic. It'll be more expensive than what we do today, but it's at least reasonable in most views. The problem with the 40 or 50% is, if you're not using natural gas because you're trying to get to net zero, then where does the rest of the electricity come from? That's a big challenge. But the challenge provides a real opportunity for nuclear power. And that's one of the things that we are watching very closely. So to start, nuclear power, and I'll note that this is a report that came out about a year ago, I think now, a report that we do in concert with a sister agency, the International Energy Agency, which looks at all energy, not just nuclear. And we found in that report something that's quite interesting. And I'll skip this chart and go to this one. And that is that if you look at all the possible ways to produce low carbon electricity, PV, onshore wind, offshore wind, the cheapest, absolute cheapest way to provide low carbon generation is to maintain existing nuclear power plants. It's that simple. It's not even close, really. If you look at this chart, my light doesn't work. You can see, oh, there it is. You can see right there, LTA, long-term operation of existing nuclear power plants, is by far the cheapest way to produce low-carbon electricity. And I know that in many countries, there's plans to shut these plants down. From a climate change perspective, it's a big mistake. There's no question about it. If you shut nuclear plants down, your CO2 emissions will go up. And I'm sure a lot of people say, well, we're going to replace them with wind. Well, yes, but you're going to back the wind up usually with natural gas. So you're seeing emissions go up in a lot of places, and it's a big mistake. Additionally, we know we're building Gen 3 plants today. The most modern, safest, cost-effective nuclear power plants like POX-2 that I know you're all familiar with are being built around the world today. There's about 50 reactors under construction in different countries all over the world. More are coming. This generation of nuclear facilities has had its issues. There's no question. There's been big cost overruns and big issues, but we've learned a lot of lessons, and I think we have a lot of confidence today that these plants can be built on cost and on schedule. The ones that are being built and planned, as you can see on this chart, will avoid about 23 gigatons of carbon emissions between 2020 and 2050. The ones coming online now and the ones planned over the next 20 years or so. So they're going to have a big impact. They could have a bigger impact. And so this chart shows, if you look above the dark blue band at the bottom, those are plants that we could build that we're not building. And maybe plants that will get started now that we get serious about climate change. But I know that most people focus on the new technology, small modular reactors and Gen 4 reactors. Those are very important. There's no question that these are a new innovation that could have a very, very big impact. These technologies provide the ability to deploy nuclear plants in a much more flexible, economic fashion. They provide the opportunity for flexible operation because they are built in modules and you can shut one module down when you don't need the power. Something that's hard to do with a large nuclear unit. They can be manufactured in factory as opposed to built on site, which make them much more cost competitive. And the model looks a lot more like building big airliners as opposed to building airports, as a person once put it. And safety is a game changer, in my view. Many of these technologies can be built in places and not built and operated in places that you couldn't build a conventional nuclear power plant. Some of the technologies, it seems, will not require any off-site emergency preparedness. That's a game changer. That means you can put the countries that are small and perhaps island nations that would never consider a large nuclear power plant are looking at these technologies because of these large safety parameters. There are many different types of these. I don't have time to go through them, but there's about 70 different projects around the world, and they range from these small light water systems to distributed systems, to floating nuclear power plants, to microreactors, and they all have a lot of different applications. And these are some of the applications that we've seen. On-grid, so in replacing coal plants and older nuclear plants. Off-grid, very small systems that are dedicated to mines or factories. There's a lot of people that think we need to put them on merchant marine shipping. Well, you probably don't think much about it, but most of the products we use today are shipped from someplace else, and they come over the ocean. And there's a huge amount of traffic with these ships moving equipment and products from continent to continent. And they are a pretty significant contributor to CO2 emissions around the world, and one of the most difficult to abate areas. What do you replace the fuel oil fired ships with? What do you use? Sails? No, you probably don't use sails. Do you use solar? No, you don't use solar. So what options do you have? Well, one option is nuclear. We've looked at this in the past. There were demonstration ships built back in the 60s. It was abandoned because people thought it was too expensive, but with the new technology, it might make sense again. So this is one to watch. And of course, the need for heat. Industry needs heat for materials processing and many other applications, and that heat usually comes from either coal or natural gas. Especially with high temperature reactors, you can replace that with nuclear. And in Hungary and a few other places, you already use heat from nuclear power for residential heat, and that's something that can be expanded even more. So, that's also a very difficult to abate area. Heat generation is about 30% of global industrial emissions. Very difficult to abate, but nuclear can solve that problem. So these new reactors can solve a lot of problems. The difficulty, of course, is that we have a lot of work ahead of us. As I mentioned, there are about 70 different projects. We're now starting to see that sort itself out. We're starting to see a few likely winners coming out of the pack. But one big problem we have is to be successful, to be like the aircraft industry, we're going to need a global market. We're going to need to be able to provide these technologies on a global basis to all countries at the same time. And quite frankly, we don't know how to do that. We're not equipped for that. We're also not equipped for any kind of regulatory harmonization across borders. But we're going to have to learn to do this. Otherwise, regulators become a barrier to progress. And if each of these technologies is only built on a national basis, they're not going to be successful because you can't build enough of them to have a big impact. So regulators are looking at this now. There's some big challenges. What I find, for example, is that many regulators around the world are not focused on these issues, are not looking at these new technologies, are not prepared for these new technologies. It's unfortunate, but it's true. Most of them are looking at the technologies in a very old-fashioned way, thinking about them as just another reactor and using deterministic approaches to regulate them instead of looking at the much, much lower risk they present. If they don't change that, it makes it very difficult to justify deploying these new technologies in those countries because the cost would be just astronomical. Regulators are going to have to solve this. We can't change the way nuclear works, but we can change the way regulators work together. So we started looking at different ways to approach this. And to try to understand the situation a little bit more, we held this workshop last year. It was really quite interesting. What we did was we invited experts from other industries, from the aircraft industry, from pharma, from a few others that do work on a global basis and provide their products on a global basis, and asked them, how do you do it? Why is nuclear different from this? And we did learn some things that were quite educational, at least for me. One thing that we found was that when you look at aerospace, and I want to use aerospace as a good example because it's probably the most relevant. When jet airliners first started to come onto the market in the late 50s and early 60s, the manufacturers from day one imagined that they were going to export these technologies overseas. So the global infrastructure immediately started rallying around, how are we going to make these products available everywhere because we need them. You know, everyone wanted to have jet airplanes, so they needed to find a way for all these countries to work together. So there was a very concerted effort to make the technologies available broadly so that these planes could be sold and used around the world. Nuclear wasn't like that. Nuclear was almost exactly the opposite. In nuclear, particularly in the 1950s, it was a very national, highly protected, often classified technology. It wasn't shared very much with other countries. Canada built reactors, the US built reactors, UK built reactors, the Soviet Union built reactors, but there wasn't a lot of exchange among them for many, many years. Another issue is that in the aerospace industry, much of the globalization of that industry is based on industrial standards. And when you look at the way industrial standards are built in the aerospace industry, and there might be some of you here working in that industry, so you can think about this. It's really done on a much more globalized basis, and it isn't just the manufacturers that are involved in the standard making. It's also the regulators, the governments, academia, many different groups, and they work together to try to advance technology. And in the nuclear sector, people don't think much about advancing technology. It's usually focused on nuclear safety and maybe some things like that, but not much about just advancing the technology as a motivation. In aerospace, you have that. So we're not going to see the psychology of nuclear change very much. So we're going to have to try to adapt as much as we can to learn from what we've seen. So we're not going to change the global framework overnight in time for the challenge that we're dealing with and leading towards 2050. We recognize that we're different. We recognize that nuclear is not going to be like aerospace and not like pharma, but we can certainly do better than we're doing today. There must be ways we can have more harmonization than we have, and we're working on that at the NEA, at the IAEA, and other places. We're working to try to find ways to do that. But I want to highlight that time is short. We can't spend 50 years thinking about this. We have to do things today, so we have to be very practical and find things that can be implemented quickly. As I wrap up, I'll just sort of highlight something that we found in looking at some work from the IPCC. So the IPCC, as it's going through its work, and it's been done a very good job, I think, of informing countries around the world about climate change and about ways to reduce CO2 emissions. They have looked at 90 scenarios from different parties. And these are just an example of some of the scenarios that we saw. You can see there's one from the IAEA, the IEA, Shell, Bloomberg, just different groups. Shell has one in there somewhere. And these different organizations, some industrial, some university-based, some from NGOs, there's 90 scenarios that the IPCC has looked at. So we did something that was actually relatively straightforward and simple. We averaged what they say about nuclear. As you can see in this chart, there's a pretty broad range of what these organizations say nuclear should do in their scenario to get to net zero by 2050. In the case of the IEA, they had nuclear growth about 98%, so double. But if you look at the Bloomberg, it went up quite dramatically to 100, over 1,600%. So we averaged this to see what the answer was going to be. And the answer we got was that if you average the 90 scenarios from all these independent different organizations, the nuclear capacity in 2050 would have to be 1,160 gigawatts. Today, we have about 400. So we're talking about almost tripling the size of the nuclear fleet by 2050. That's the average scenario. So it seems pretty clear to me that most people who are looking at this around the world think that nuclear is a big part of the solution. It's not the only part of the solution, but it's a big part of the solution. And nuclear actually helps renewables because with renewables variability, they need to have dispatchable technology that can balance. So as part of a whole, it makes sense. But of course, one question we asked ourselves, well, can we grow nuclear that fast? So we took a look. The green line is the 1,160 gigawatts, and we looked at different scenarios of how you might build out. And when we looked at it, you can do it. It requires keeping the existing reactors in operation. It requires continue building the Generation 3 plants. But most importantly, it requires a pretty quick increased construction of SMRs and Gen 4 reactors. And that, of course, is the more difficult part because we don't have them on the market yet. But if we do that, we think you can get pretty close to that number and be able to meet the targets. The problem, of course, is that there's a really big gap between where we are and where we need to be. So part of the challenge will be over the next few years to close that gap. I think a lot of that gap will be closed by the SMRs if they're successful. And that if is very important. I think I always look at these things very soberly. I've had too many experiences where industry has promised to deliver something and not quite pulled it off for one reason or another. So this time, the industry really needs to be successful. They need to be successful in demonstrating and licensing these new technologies and bringing them to the market in time to have an impact on 2050. If they don't, well, we've got a big problem. And this is important because I look at it this way. So when I talk to NGO groups around the world, I very often hear the story that they think that the real problem isn't how we make electricity. The real problem is we use too much. We use too much energy. We're greedy. We're wasteful. And if we just stop using so much resources, perhaps we would be able to save the environment. And so you hear a lot of them advocate that we need to stop driving so much. Give up the cars, ride bicycle more. And you see people in a lot of countries riding more bicycles. And of course, we had the young lady that took the sailboat to New York instead of flying to help reduce CO2 emissions. Although I think next time I go back to the U.S., I'll stick with the airplane. And I've even heard people suggest that all this billion people, well, it's like 1.2 billion people that don't have adequate electricity, don't have clean water, their children can't study at night because they don't have lights. Tell those people, well, maybe it's going to take a little longer before you can reach the middle class that we have in OECD countries. Maybe you have to wait a little bit. Well, the answer to all these questions is going to be no. Public and developed countries like Hungary and France and the United States, they're not going to give up civilization to save the environment. I'm sorry, they're just not. Some of them will give up meat, some of them will ride bicycles, but you think most people are going to give up the air conditioning in the summer and stop driving and stop taking airplanes? No, they're not. And how do you tell people in Asia and Africa that you just can't have it because it's bad for the environment? You can't, and they're not going to listen anyway. So the answer, I think, is we need to have a solution that enables us to both save the environment and maintain the ability for people to have economic growth and social progress. That has to be the answer. We can't choose between the two. And in my view, nuclear plus renewables and other technology provides a very realistic, viable roadmap that can get us to that place, get us to where we can save the environment and maintain economic growth. We can eat our cake, and we can have it too. And if we don't do that, we will fail. And it isn't just a failure for the nuclear sector. And I think it's very important. With nuclear people, as I talk to, and some of you are doing nuclear, it isn't just about nuclear power and nuclear technology. It's about our societies. It's about the future of our planet. Because if nuclear fails, from all the work that I've seen, I think the chances that we will fail overall in trying to deal with climate change is very high that we will fail in that as well. So it's something that we all have to work on together. So with that, I will conclude and see if you have any questions. But very nice to be back in Hungary. It's only my second trip to Hungary, so but I was going to come back third trip. Excuse me. What was the first trip? All right, second. But the first trip was very short, though. Oh, right. Okay. All right, third trip. Excuse me. Third trip. My second trip here, though, right? But I look forward to coming back again. In fact, I just already promised this morning I'll be back in the spring. So, any questions?